everyone, Miss Meek here, and today we are going to be talking about algebraic relationships. This is video number 3 about algebraic relationships. However, this video is going to focus on graphs and writing equations. And equations are slightly different than the rule, and we're going to talk about that in video number 2 for algebraic relationships. We talked about writing the rule. If you have not watched that video, I encourage you to watch it because writing the rule is pretty much about 90% of how to write an equation. So if you're not sure about how to write the rule for a table, or for a relationship, then you may want to check out that video first because, again, writing the rule is about 90% of the information, the knowledge that you need in order to write an equation. So first of all, when we do these equations, they come from tables, they come from graphs, and so tables are our best friend. So we are really good at tables. They're like little math machines. Our whole job is to figure out what's happening to these inputs in order to get these outputs over here. And so that is our whole job with these tables. So let's go ahead and figure that out because the first step into figuring out the equation for a table is to figure out the process or the rule for the table. So what I'm trying to do is figure out, okay, what's happening to these inputs in order for me to get these outputs. So what do I have to do to this 1 in order to make it become a 9? Now, there's a couple of things that I could do. I could multiply it times 9. I could add 8. And so again, I always want to check more than one row of my table to make sure I have the right process. So I'm going to start off by multiplying times 9. So 1 times 9 is 9. Okay, check. 2 times 9 is 2 times 9, 18. Yes. 3 times 9 is 27. 4 times 9 is 36. I have a pretty good feeling I figured out the rule here. And 5 times 9 is 45. So the process, the rule that's happening in this table is whatever these x's are, I am multiplying them times 9. This right here is our rule or our process for this table. It's what's happening to my inputs in order to get my answers, my outputs. So what we're going to do is we're going to take that rule. Now remember that when I write x times 9, I can also write it like this, and I can even write it like this. And this is actually the way that we really want to get used to seeing it written, because as we get into algebra, we need to be able to write variables with what's called a coefficient. And that coefficient is the number that is attached to the front of that variable. And so we want to make sure that we understand that all of this equals 9x. These are all the same things. They're all equivalent forms. So this is what I'm going to be using. I'm going to be using 9x. All I have to do to write an equation is I have to have an equal sign. Okay, so I have to have an equal sign, and it has to equal something. Well, what does 9x equal? Well, 9x equals my outputs over here. 9x equals my output because I'm plugging in these x's right here, and they're spitting out these answers. Well, maybe you didn't notice this or not, but we actually have a second letter now in our table, a second variable. Our outputs are represented by the letter y. And so what does our rule equal, that 9x equal? 9x equals our y. So this is what our symbols would look like. And actually that would be my equation. Y equals 9 times that x, or 9x. So again, our inputs, we plug them in. So we plug them in, and then they equal, and we get out our y's here, our y's, okay? So that is where those letters are coming from. This is my x is being plugged in, and it equals that output, which is they're using a letter y to represent the output. Again, just as a quick refresher, remember that this is our output, and what our output equals is 9 times the input. That is what those letters represent. Okay, that's what those letters represent. Again, the output is also known as the dependent quantity. So don't forget that vocabulary word, because our answer depends on what we plug in, and our input is known, I don't know if I have room here, but I'll try, is known as our independent quantity. So don't forget those other vocabulary words that we talked about way back in our first algebraic relationship video. So let's go ahead and take a look at something else they could throw at us. Now that we have an equation, we can actually graph these things. Again, I've told you this before in previous videos, tables are our best friend. It's really hard for me, even as a math teacher, to look at that equation and then throw it onto this graph. The first thing that I really need to do, step number 1 here, is going to be to create a table, because when you create a table, you are getting organized with your information, and then it's easier for you to make a graph. Okay, so to create a table, I'm going to do a very simple table where I'm going to have X, and I'm going to have Y, and in the middle, this is where my process is going to go. And remember, my process is this rule right here. That's our rule, and it's everything in that table is getting multiplied by 4. Now, you may be wondering, what am I going to multiply by? Well, remember in a graph that these are your x-axis. Your x-axis, meaning these are your x values. So in my table, I'm going to plug in these x values. And then I'm going to be solving for my y-axis values, y. So again, just as a reminder, that's where these letters come from, your x and then your y. So again, the whole idea, I plug in these x's right here, and I'm going to show my work in that middle column. So 4 times 1 is going to give me a 4 for a y. So my first point is going to be 1, 4, and so we'll talk about what that looks like in just a second. The next one is 4 times 2, so that's going to be an 8. Then I have 4 times 3, which is 12. I'm going to have 4 times 4, which is 16. And then I'm going to have 4 times 5, which is 20. And so now I can take those points and plot them. Just as a quick reminder, remember we plot points x, comma, y. X is which way we go, left or right. Y is which way we go, up or down. And we do X and then Y. So just like think about going in an elevator. We have to walk to the elevator first before we can go up or down in it. So our first point is 4, 1. So I'm going to go over to 1, and then up to 4, and then put a dot. My next point is 2, 8. So over to 2 and then up to 8 and put a dot. My next point is 3, 12. So over to 3 and then up to 12 and I put a dot. My next point is 4, 16. So over to 4, up 16, and then last point 5, 20, over to 5, and then up to 20. This is a graph. So connect the dots and put an arrow at the end to show that that line would keep on going if my graph was bigger. Now this type of line is a straight line. It's increasing upward. And here in this chapter, we are going to be talking about algebraic relationships. And this is a type of algebraic relationship called a linear relationship. A linear relationship, the reason why it's called linear is because it creates a straight line. Simple as that. Linear or linear, if you need help remembering it, means that it just makes a straight line. And here in 6th grade, those are the types of graphs that we're going to really be focusing on, are linear relationships. Let's take a look at one more example here. Again, they can give us a graph and ask us to write the equation. Same thing as before. Step number 1, before you even get started doing anything, create a table. A table helps organize your information. It is your best friend. So this time, though, my table should be really easy to make because all I'm doing is pulling that information off the graph. So remember that these down here are your x values, your x's on your x-axis. And then over here, just as a reminder, this is your y-axis, so these are your y values. So my first point is over 1, and then it's up 2. So I'm writing my x's and my y's here. The next point is over 2, up 4. My next point is over 3 and then up 6. And then that last point is over 4 and then up, up 8. Okay, so there's my table. Now, to write an equation, you have to know what's going on in the table. Step number 1 is figure out, okay, what's the rule of my table? What's happening to these numbers? And a table organizes your numbers nicely that you can see that pattern better than me just looking at my graph and trying to figure out what's going on. So what is happening to this 1 to make it become a 2? That's what we're trying to figure out here. So I can either be adding 1 plus 1 is 2, or I'm multiplying by 2. So if I add 1, let's see, 1 plus 1 is 2. That works. 1 plus 2, is that 4? No, it's not. Okay, so I'm not adding 1. Just kidding. That's not what we're doing here. Let's try multiplying. So if I multiply 1 times 2, that gives me 2. Is 2 times 2 4? Yes. Is 2 times 3 6? Yeah. Is 2 times 4 8? Yes. So my rule is the numbers that are in this first column, my x's, I am multiplying them times 2, and that equals the y's. So I'm going to kind of clean this up and write my final equation. My final equation is going to be my y equals, because remember an equation has an equal, 2 times those x values. And I can write that as 2x. 2x is the same as x times 2 or 2 times x. Okay, so again, what we just wrote here in words is our output equals 2 times the input. That's what we're writing, but we're using symbols and variables to write that. Alright guys, I hope that helps clear up how to write equations from tables and from graphs, and how to take a table or take an equation and put it on a graph, all of those different combinations. I will be talking to you later. Bye!